Imagine this: a sleek, cutting-edge spacecraft blasting off into the vastness of space. But behind that moment of awe, behind every launch, is a story of years of intense work, trial and error, brilliant minds, and extraordinary technology. Building a spacecraft is not just a feat of engineering. It's a culmination of humanity's ambition to explore the unknown. But how does a spacecraft go from being a mere concept to defying gravity and reaching the stars? Today, we're going to uncover the fascinating process of how a spacecraft is built, step by step. Where an idea is born, where materials are tested, and where dreams take flight. Let's dive into the incredible journey from concept to launch and explore just how much goes into making one of humanity's greatest technological achievements. It all begins with an idea, an ambition, a vision of what the spacecraft must accomplish. The initial concept phase is where everything starts. This is where the mission's purpose is defined, and it's where engineers and scientists start to map out the path forward. The mission's goals are paramount. Is it a human-crewed spacecraft designed to carry astronauts on a journey to the Moon or Mars? Is it a robotic spacecraft meant to explore distant planets or gather data on asteroids? Maybe it's a satellite that will orbit Earth, monitoring weather patterns, enabling GPS, or communicating with other spacecraft. Every mission is unique, and the design of the spacecraft will be tailored to meet those specific needs. From this, engineers begin creating an initial blueprint, a rough sketch of what the spacecraft will look like, its size, and its key components. They must also consider the spacecraft's power source, propulsion system, thermal protection, and more. All these elements must be weighed against the challenges of space itself: extreme temperatures, radiation, the vacuum of space, and the mechanical stresses experienced during launch and re-entry. But designing a spacecraft isn't just about imagining cool new technology. It's about answering tough questions. What materials will keep it safe? What propulsion system will make it travel at the required speeds? How do we ensure it survives re-entry without burning up? These are the questions that drive the early stages of the spacecraft's life, and the answers will set the course for the next stages of development. Once the initial concept is clear, the real design work begins. Engineers begin creating detailed computer models using advanced simulation software. These simulations allow them to test the spacecraft in a virtual environment before any physical parts are made. The design phase is full of tough decisions. Should the spacecraft have wings, or will it be wingless, relying on rocket propulsion to maneuver? What kind of engines will be used? How will the spacecraft structure handle the extreme forces of launch and space travel? Each system, propulsion, guidance, communication, and life support, needs to be meticulously designed to work together seamlessly. This stage is not without its setbacks. Engineers may discover that certain materials or systems don't perform as expected. For example, the spacecraft might fail to meet efficiency standards in a simulation or face heat resistance issues in specific sections. These issues can lead to redesigns, which often means going back to the drawing board. After these initial designs, engineers begin building prototypes, physical models that can be tested in controlled environments. These prototypes are critical because they allow engineers to see how the spacecraft's components actually function in the real world. Testing in extreme environments, vacuum chambers, thermal chambers, and vibration tables helps simulate the conditions the spacecraft will face in space, ensuring everything holds up under pressure. Once the designs are locked in and prototypes have been tested, it's time to move from the drawing board to the factory floor. Manufacturing a spacecraft is not like assembling a car or an airplane. It's much more precise, much more delicate, and the stakes are far higher. Each part of a spacecraft is meticulously crafted, often from specialized materials that can handle the extreme conditions of space. For example, the outer surface of the spacecraft may be built with materials that are resistant to intense heat during re-entry. The engines need to be engineered for maximum efficiency and reliability, as a failure here could be catastrophic. One of the most challenging aspects of spacecraft manufacturing is the need for absolute precision. A single miscalculation or small flaw could cause a system failure during the mission. That's why spacecraft are built in clean rooms, specialized environments where even the smallest speck of dust can be the difference between success and failure. As the spacecraft begins to take shape, thousands of individual parts come together. Fuel tanks, life support systems, engines, control systems, and heat shields, all are assembled with precision. The assembly process can take months or even years, depending on the complexity of the spacecraft. Before any spacecraft is cleared for launch, it must go through a battery of tests. These are perhaps the most crucial moments in the development process, as they push every part of the spacecraft to its limits and beyond. First up, vibration tests. The spacecraft is subjected to intense vibrations designed to simulate the powerful forces of launch. Rockets create an immense amount of energy during takeoff, and every single component of the spacecraft must be able to withstand those forces without breaking down. Then, the spacecraft enters thermal testing. Space is cold, and re-entry is hot. A spacecraft must be able to handle both extremes. Engineers test its thermal resistance, ensuring that it can survive the heat of re-entry without disintegrating. Heat shields, engines, and materials are put through these tests to make sure everything performs as expected. Next comes vacuum testing, simulating the empty void of space. Without an atmosphere, the spacecraft must rely on its own systems to maintain pressure and ensure proper conditions for its crew and equipment. In the vacuum chamber, the spacecraft undergoes a series of tests to make sure the pressure seals hold and everything remains functional in the absence of air. And of course, no spacecraft is complete without checking its life support systems. If it's a crewed mission, oxygen, water, temperature regulation, and waste removal all must work perfectly. Crew members, if any, must have everything they need to survive for the duration of the mission. After these tests, there are sometimes failures, unexpected issues that demand further refinements. This stage of testing is long, grueling, and can be frustrating, but it's essential to ensure that the spacecraft will perform flawlessly when it's time for the real thing. With testing behind them, it's time to move to the final stage, preparing the spacecraft for launch. The launch site becomes the final arena where everything comes together. The spacecraft is carefully transported to its designated launch pad, sometimes thousands of miles from where it was manufactured. The final systems checks are completed, and the spacecraft is prepped for the high-stakes event ahead. If it's a crewed mission, astronauts undergo final training and medical checks, ensuring they're physically ready for the stresses of spaceflight. They'll also practice emergency procedures, so they know exactly what to do in the unlikely event of a system failure or emergency. The spacecraft itself is fueled, whether with liquid oxygen and hydrogen or other advanced propellants. Each fueling step carefully monitored to ensure everything is in perfect working order. Every component of the spacecraft is double-checked, and the final countdown begins. The mission is now in the hands of the engineers, the astronauts, if applicable, and the entire team who made it all possible. The moment has finally arrived. The spacecraft is ready to launch. The countdown clock ticks down, and the world holds its breath. The powerful engines roar to life, and the spacecraft begins its journey to the stars.